thank you for that welcome. I should have kept my mouth shut last night. Anyway, just it's the end of the day. I was given the brief to navel gaze on new technologies. I'm the youngest person up here, so I don't know if I'm qualified to navel gaze yet, but we'll start off with going somewhere a little bit different. And also, when you're the last speaker of the day, everyone's covered things, and Sir Ray kind of did my first bit. So, what is science? Okay, so you put out word frequency graphs. Go to the internet, you can find them everywhere, word frequency graphs. What is science? Well, it's great to know it's scientific, it's about method, it's about knowledge, it's about inquiry. But when we're looking at biosecurity, the most important thing for me is about, and if this thing's gonna go, is about observation, and that's what Sir Ray was telling us about. So for us to identify threats and to know about risks, we need to be able to make observations. And we have certain tools available for us at the moment to be able to make an observation. And how we're going to change our biosecurity practices and make that step to another level is a technology that allows us to make an observation in a different way, or a way that we couldn't do before, and that opens up new knowledge for us. So, how do we make observations? There's a great delay here. So this is a way of making observations. This is a platform. I am a platform. I come with 2 legs, I can walk around, and I have a number of senses. I have touch, I have smell, I have sight, so I can look for things, and that's what I'm doing there. But humans are not necessarily the best platforms for making observations for biosecurity. Okay? An alternative that we use now as business for usual are dogs. Slightly different platform. They've got 4 legs, they move around, but they've got a much better sense of smell. So we use this as a tool. Auckland Council is using it for Argentine ants. We use it at the airports for looking for food. Okay, so what I'm going to talk about now is a few platforms and potential sensors for biosecurity and for surveillance in the future. So let's start with platforms, because platforms are the things that carry stuff around. They don't actually do anything for you, really, in terms of biosecurity, other than it moves things around the landscape for you. So one of those is UAVs. They're all the rage of the future, but they don't actually do much other than fly around, and it's what you put on them that's going to make the difference. Smartphones are another platform. It's just a means of communication, information exchange, and I don't think we're using them enough in biosecurity. There are hundreds of thousands of apps out there that you can download. There are probably more torchlight apps than there are apps that will help you in biosecurity in New Zealand. We need to be building more of them. That's an example of one that MPI has just funded. We're going to be going live with that in the next week or so to help with looking for beetles on eucalyptus pests. And we're hoping to kind of supersize that in the next couple of years with a co-innovation approach with MPI, regional councils, and we've got most of the primary sectors on board, of which many of the people are here today. So that's looking forward great. The Internet of Things, so that little green smudge down there over Christchurch is actually the communication map for one node from the Kotahi network off the Sugarloaf Tower. So if you have a sensor that can interface with the Kotahi network, one AA battery will last you several years to communicate with that tower. It's an absolutely amazing platform, and that's what's enabling the precision agriculture and putting these sensors out there in agriculture like temperature and humidity and moisture. And those are easy things to do and to monitor, but as we heard just before, finding biological things is much harder. You're not just trying to measure temperature. Okay, so platforms of the future. Where are we going to go in the future? I think we're going to have more robots. There's going to be more, we're going to have autonomous cars maybe, if we can get through the regulatory barriers. We're probably going to have robots that are going to help us move around. In forestry, in the area that we are, will we see tree-to-tree robots? Will we see armed little vehicles moving around the forest? Again, they don't really do anything other than move around the forest, but we can put interesting sensors on them so we can do things. Will we have humanoid robots? So if anyone hasn't seen Boston Dynamics, I suggest you go and look at it. It is scary. It is frightening what these robots can do. They can move through uneven terrain. The video actually has later on a guy with a hockey stick smacking in the chest, and the thing just bounces back and then comes back, picks up a package and puts it on the shelf. They're absolutely frightening what they can do. But again, it's for carrying stuff around. It's probably been to the bar, that's why it's a bit wobbly. We're also in the space race, as was pointed out earlier by Sir Ray. Peter Beck, we haven't got Cape Canaveral, we've got Cape Mahia. We've got the Mahia Peninsula and we've got the Centre for Space Science Technology now down in Alexandra. And in the next year to 2 years, they're going to be launching CubeSats. If you haven't seen a CubeSat, that's roughly what they are. They're about 10 or 12 centimetres by 10 or 12 centimetres. And you can put stuff in them, and pretty much there's quite a lot of people in this audience that actually have salaries that could afford to send one of those in space. There are schools around the world that are sending these into space. So, you know, what might we put up there that would help us for biosecurity? Again, it's a vehicle. A CubeSat is something up there. It's what you put in there. Okay? I can't really tell you what those sensors be. I don't know. They're yet to be developed for potential for biosecurity. But I thought I would show you where have we come in 40 years of optical sensors from space. Smell sensors from space probably won't work. Touch sensors definitely won't work, but optical sensors will. So where have we gone in 40 years? So this here is the first ever image from the Landsat satellites of Auckland, February 1974, and they were ecstatic, 59 by 79 metapixels. From a biosecurity perspective, about the only thing you can say is the harbour bridge was built. You can see it there. But where have we come in 40 years? So in 40 years, now we've got Google Earth. Every single person in this room can hop on their computer and they can zoom in on the landscape and they can see individual trees. From a business perspective, this is amazing. If you're a trampoline salesman, Google Earth is your friend. You can see where all the trampolines are and you know which houses you don't need to go and visit because they've already got them. That there's a golden elm tree and it tested positive for Dutch elm. So we know that tested positive for Dutch elm. We could remove that, but we could also go and look in the landscape where are the other Dutch elms that we might want to remove that are close by. We do know that that Dutch elm has gone. I don't know if it went for biosecurity purposes. We'd have to ask Auckland Council if they removed it. It's more likely it went for that infill Auckland housing thing. You can see there's a new driveway there and actually all of the vegetation's gone. So I'm assuming when we see the next picture on Google Earth, there's going to be a house there. But yeah. So what other sensors are there other than optical sensors? Well, there's smelly sensors. There's smell. And people have been talking that earlier today, things like volatile organic compound sensors. There are lots of people around the world. We've got some people in the audience. Where's Andrew? He's somewhere around. They're working on, there he is. He's got the nose for sensing. Talk to him afterwards. So there's groups in New Zealand looking at this, nano-sized sensors for sniffing out things. We've also got things called colorimetric sensor arrays. And so this is basic high school chemistry, really. You add one compound to another and the colour changes. But what you do is you get a little postage stamp sized bit of paper and you print on it lots of little ink dots, 80 different ones of these. And then there's some groups around the world that are using these to look at the vapour profiles above substances, particularly around blood and blood-borne diseases, so that they can segregate between them by the unique fingerprint of the changes in colour across those 80 different chemical reactions. There's a group from America that's looking at those to create little postage-sized stamp sensors to go inside containers, specifically for Kuiper beetle, because they've been having some issues around there. I'm not sure how far they've got with that, but apparently they're working on it. Sensing by sound, so plant and food are doing a thing called wing beat frequency. So this is a little trap with a little optical curtain in there. You can see little LEDs in here, and so when the moth goes through that trap, as its wings are flapping, it breaks the optical curtain, and from the frequency of that you can get actually species-specific, in some cases, knowledge of what's gone into your trap. Sound is another thing. The noise that you're about to hear, if the sound is up, there it is, sounds like a bad Cessna coming into land. That's actually the sound of a brown mum-rated stink bug. It's kind of an odd sound, isn't it? So if you look on this little thing here, you can move this, the laser's not going to work, but anyway, on the side of that little container is a little microphone, and what some people at SCION and the University of Canterbury are doing is looking at the type of sounds that they produce, and can we then hear these things in shipping containers, or alternatively, can we use sound as an aggregator to try and drag things to particular traps. There's other examples of this overseas where we know things like gypsy moth don't like the sound of bat echolocation, and they'll drop out of the sky to try and avoid the bats. So can you stop gypsy moths from flying around by playing them bat sounds? Who knows? So automation, this is another thing that's coming along, automation in terms of image ID and being able to identify things. Now I want to be very clear, this is not going to replace taxonomists. So all the taxonomists in the room, you're very much safe, you're very much needed, because to develop these tools you have to have libraries of images that you know what it is, and you're not going to get that without the actual taxonomist there to tell you what it is that you're looking at. This one here in particular is a collaboration between University of Waikato and Langkaer, and basically you use a supercomputer to do your heavy lifting of classifying what all your images are, and then you can query that database, and very rapidly you can get back an answer saying whether it thinks that image is in your library or not, and how confident it is. So, if you found something and you know you have to take action, you're going to need new tools to try and do things. And our last speaker did a lot around genetic tools, and I thought I'd just show about RNAi. It's not traditional genetic modification. What it is it's about feeding, effectively, small double-stranded RNA to the organism, which is designed to knock out the expression of particular genes of interest. And in the case of what they're doing at University of Otago, is looking at ways to try and knock out the reproductive gene expression in queen wasps. But obviously, as Sir Peter was talking about before, public acceptability of new technologies is going to be a key thing in the future, and that's a big focus of the Urban Battlefield program that's been run out of SCION at the moment about new technologies for eradication. Now, in terms of public acceptability, when you're taking action and you're wanting to go and make an intervention, the ability for you to make an intervention is going to be reflect the level of immediacy and the level of threat that the person is under. So, for example, if you're James and you're down there and your pack house is being threatened by a rural fire that's rolling across the Bay of Plenty countryside, he will be very happy to see this DC-10 coming along the landscape, and he will be quite happy to see this red smoke because he wants that fire gone. But if it's not an immediate threat to your life or your property, and it's maybe just an incursion of a tree-eating moth, how happy will you be around a similar process? Maybe in the future a more targeted approach could be better, and so this is one example. Heli Resources from the Bay of Plenty is developing a UAV-based spray pack, and the developers will be here outside in the networking reception area if you want to see this UAV. They won't be flying it inside, sorry, but you'll be able to see and have a chat to them. SCION is working with these guys looking at new atomising spray nozzles to see how we can deliver targeted insecticides into canopies in urban areas so we don't need to rely on more broad-scale applications. So, lastly, where are we going to be in 2025? I have no idea. I'll be a bit older. But things are definitely going to be smaller, they're going to be faster, and everything's going to be a lot more automated. And we're going to have a lot more new platforms that we haven't thought about, probably robotic platforms, and we're definitely going to be making use of space. I'm sure we will. Power is a huge challenge for a lot of the sensors that we use today, particularly with their communication platforms. I think we're going to solve the communication platforms in the next 10 years. I think that challenge will be overcome. The power challenges we have for today's sensors will be overcome, but our new sensors will probably be more power hungry, so we'll always be looking for a better battery. And definitely raising the public awareness. We have to bring the public along. If we're going to use these new tools, we're going to need their acceptance for that, so we've got to bring them along with the challenge, and we have to front foot it. We need to be using these technologies overseas as well. And finally, the technology is advancing very rapidly. We have new technologies all over the world being developed for all sorts of things. But the majority of the people who are developing these technologies are not doing it for biosecurity. There is more money to be had in making computer games and entertainment and things like that. So if we want to build the toolbox for tomorrow, we have to bridge these amazing technology developers with the biosecurity problems. And B3, Dave Toulon and Jacqueline Beggs, had a workshop a few weeks ago in Auckland trying, as an initial stage, to bring together things like the engineering departments, chemistry departments, with the biologists who had the problems to try and discuss how we might solve those. And we need to do more of that if we're going to meet the challenge ahead. Thank you.